Hey everybody, it's Joel. I was going to record this video down at Boom Comics this evening, but they are having a tournament down there, while I'm very excited that they're doing so well and having so much business, it wasn't a good environment to be recording in, so instead you get to meet my hot pink and black polka dot bedroom. Yes, I'm never going to explain that to you, nor am I going to explain to you why there's a black light in that light right there. It's Nunya. All right, what we're here to talk about today is cosmology in the Dryden Universe. This is the universe as perceived by the folks living in the year 2503, which is Dryden Standard Time. And the idea here is to set some sort of sciencey sounding background for folks that want to talk about cosmology for whatever reason, how the universe came to look like it does. I want to stress early on that this is bullshit. Part of the role that I play in Dryden is laying foundational pieces for things for folks to grow and build on, and I absolutely love and get into the nitpicking and, well, it worked this way in episode 7, why didn't it work this way in episode 9, and so on and so forth. But this is meant to sound science-y rather than to be science. The couple of things that I'm doing here that are relevant to game development. I'm not a big fan of time travel. I've seen a lot of series really hurt themselves and hurt their continuity with time travel, and you'll notice that the way I have the universe set up precludes time travel pretty extensively. And then part of this is just this very cool image of the universe that's cobbled together from several different sort of pseudoscience sources that I liked, and so here we are building our own universe. I threw a lot of the elements that I like in. Of course, if you don't like these, you are free to not pay attention to them, and really in any era other than the primer, to pretty much disregard them completely. Certainly by Codex 2, none of these rules really matter. All right, so this is the way the universe is perceived in the year 2503. And the first sort of foundational concept that pervades thinking in 2503 is that the universe is actually a higher dimensional sphere, and humans are limited by the number of dimensions that they can see in terms of their ability to actually see what the universe looks like. So I'm going to give you kind of a description for that, and I'm going to draw it out and see what the universe looks like once we've got it. And what I want you to think about is I want you to think about if we had a piece of fiber optic cable that we were able to look down, right? And we looked down this piece of cable, but as we were looking down it, we twisted that cable around so that the two ends met. And then when we look down the line, in spite of the fact that there's space out here in front of us, our eyesight would be trapped by the fiber optic cable, and we would eventually look at the back of our heads. Okay, and that's kind of easy to follow. We can imagine looking down this line and not being able to look up or out or around, and looking around. Now, what I want you to imagine is that this person that is inside of this line is unaware that they are looking around the circle. They believe that they are looking in a straight line. Okay, they're not. They're looking around a curve and it's coming back, and they're actually seeing the back of their own head. But they don't know that. All they've ever seen, they've never been able to look this direction or this direction or this direction. They've only ever looked around this line. In the Dryden experiment, the universe is actually a higher dimensional sphere. It started from a very small state and it grew larger, but there are dimensions of the sphere that are higher dimensions than humans can perceive. So when we look out into space, we perceive that we are looking flat in a straight line, but we are in fact looking around a higher dimensional surface. And if you look far enough into space, and this is on the order of, I think I decided something like 1.2 billion years at this point in the galactic or universal evolution, what you actually do is you arrive at the point where you have looked all the way around that hyperdimensional sphere and are seeing the same point in the galaxy, or the same point in the universe universe and not realizing that you have actually looked around. You believe that you're looking straight. And so every time any of us look any direction in space, if we look at a line, imaginary line, I'm calling it 1.2 billion years, so let's just stick there, light years out from us, you are actually looking at the same point in the universe that the Milky Way is occupying now. Now, it's hard to reconcile because the Milky Way is not there. Things are moving around the surface of this sphere as time goes on, and so the object that exists at 1.2 billion light years away is not the Milky Way. There's something else at that location 1.2 billion years in the past. But if you look around and around, the universe is about 15 billion years old, and it's been expanding as we go along. So if you look out 1.2 billion years, well, then something like 800 million light years back, which ends up to be 2 billion light years, so 1.2 out and then 800 more, you end up at that same point again, and then about 500 million more, so about 2.5, you end up at that same point. And what you discover is that we are looking back down the sphere older and older, and the older it is, the smaller it is, so that the very oldest iterations, it's very, very small, and we can see around the surface very quickly. And this was eventually sorted out because some things have survived multiple cycles around the sphere. For example, the black hole at the heart of the Milky Way galaxy has a unique signature, just as a possible way that this might be identified. And so we can look out into space at a distance of 1.2 billion light years all around us and find an object that has the same chemical signature as the black hole at the center of the Milky Way galaxy. Other supermassive objects, galaxies with unique compositions, etc., that are long enough durations you can see appearing again and again if you look further and further into space. And we perceive that we look straight out, but actually we're looking around that sphere. We're trapped inside that piece of fiber optic line, and we're not aware of it. Okay, so this gives us a finite-sized ball that is continuing to expand, coming from this moment that is the Big Bang. Okay. Well, the Big Bang is not a singularity in the way that we think of it as a singularity. One of the postulates that I have in my universe is that as this ball forms and expands, for a few seconds, all of the matter, or a few fractions of a second even, all of the matter in the universe is here with us, but it decays, and that's actually following physical science. Most of the matter in the universe didn't survive the first few fractions of a second. It decayed and it vanished. And we are actually experiencing that decay today. Things continue to fall out of the universe. But what's happening is, in the same way that fundamental particles can switch from one kind of particle to another kind of particle, from a mass particle to a massless particle, those particles can fall out of our perception of time. It's actually the way that they interact with other particles stops happening, but we perceive them as stopping moving in time, and they begin to move back towards the Big Bang at that point. They shift out. So at the very early seconds after the Big Bang that we perceive, the matter is all on our side, but it immediately begins to fall out to the other side because that's the natural state. Our time perception is actually counter to the natural time of the universe, which happens back the other way. So the further forward we go in time, the more of the fundamental particles fall out and fall out and fall out, and eventually our time ceases to have any mass in it. Okay, it's all fallen back to the other time, which is headed back to the Big Bang. So we have this multidimensional sphere that also rolls back in on itself, or higher dimensional sphere that also folds back in on itself, back towards the moment of the Big Bang. So more and more of the universe heads into counter time. Now, here's what that explains for us in the physical world. Dark matter and dark energy are the residual interactions of matter that has fallen to the other side. So matter that will fall to the other side in the future and is traveling back past us in time, we are currently experiencing its mass as gravity, dark matter, and its energy as dark energy, because it still very weakly reacts with our side of time. Okay, so let's just sort of recap. What we actually have is we have a very small ball that expands, and we can look back around the surface of it, and we perceive that we're looking out into space, but actually we're looking over the surface of that hyperdimensional sphere at earlier points in time that are actually the same point on the sphere. Hard to identify, though, because pieces have moved since then, but it can be done. We can identify things multiple iterations back, okay, multiple loops around the surface. We have also explained dark matter and dark energy because as we go forward in time, matter falls out of our sense of time into a different kind of fundamental particle that moves back towards the Big Bang. And in that way, while the Big Bang is a singularity from our perspective in time, it is an ongoing event. We are an enclosed system. The universe is an enclosed system that feeds back to itself at the beginning of time, at the beginning of our time in the Big Bang. Now, what that does is it sews up some sort of nasty holes. Where's dark matter? Where's dark energy? I don't know. I'm not a physicist. The physicists don't seem to know. I know in our universe. We've accounted for it. We know where it is. And the other thing that we've done is we've set up an environment where if you wanted to travel back in time, that's possible. The problem is you're not coming back until the Big Bang. So we're not going to have those great cosmological disasters, continuity disasters, when somebody gets the idea to start time travel in their universe. All right, so that was, in 11 minutes and 15 seconds, the biggest load of bullshit you've ever heard about the cosmology of the universe. Thanks for joining me.